Welcome to the Hartlepool College of Further Education GCSE Maths lesson. This one is week 5 and this one is all about fractions of amounts. Pause now. Okay, so looking at the starter questions there. Work out, then it's got in brackets 12 times 7 plus 16. So remembering back to BidMaths, we did the thing with brackets first. So 12 times 7 is 84. And we add on the 16, gets us 100. And the second one, we have 7, then in brackets 7 add 2 times by 2. So remember, here we're doing the thing in brackets first. So that's 5 add the 2, gets us 7. And then we'll multiply by the 7 on the outside of the bracket to give us 7 times 7 is 49. And then we're multiplying it all by 2 to get us 98. Next one, it says, which is bigger, 2/3 or 3/5? Now, this might be just obvious to you, and you might just say, well, that's going to be 2/3, but always good to have a method for this. So what we'll do is we'll convert them to decimals, and then we'll converting so that they are like to like. So what we'll do is top number divided by the bottom, so 2 divided by 3. 3 isn't going to 2, so 0 times. Some decimal points and zeros are there ready. I didn't use that 2, so it carries back a column. And then 3 goes into 20 6 times, remainder 2. 3 goes into 20 6 times, remainder 2, and so on. So that's going to be 0.6 recurring. So dot above the 6. And the next one is 3/5. So that's going to be 3 divided by 5. Well, 5 doesn't go into 3, so 0 times. Again, get some zeros at the ready. I didn't use that 3, so that 3 carries back a column. 5 goes into 30 6 times. Nothing left to carry, so that one is just 0.6. So the difference there is that 2/3 is 0.6 recurring, so 0.66666 and so on, whereas 3/5 is just 0.6. So the bigger one is 2/3. Next up, some quick mental arithmetic. 9 times 11 should get us 99. 6 times 7 is 42. And then on to some percentages. So 15% of £15. Quite common to get the answer 1 for this, but it's not. So let's have a look. Start with a 10% chunk. So 10% is divided by 10 gets us £1.50. And the 5% is half of the 10%. And a lot of people have problems dividing 1.5. So if you think of it in money terms, and that's £1.50 divided by 2 gets you 75 pence. Add the two together, and that's £2.25. And then 40% of £480. Well, again, let's start with 10%. Whoops. Look at that. 10%, 48, is 48 rather, and we want 40%. So if we just times that by 4, so I want 4 lots of 48, so that's 192. So £192. Next up, the number machine. So 40 times by the 2 gets us 80. Add on the 7 gets us 87. And then working backwards, we start with the output of 97. We do the opposite. We take the 7 away, leaves us with 90. We then divide it by 2, gets us 35. Prime factors. Write 7 is a product of prime factors. Now, we haven't done this one as yet, so I'm hoping we can remember this one from school, but there is a lesson coming on it. This is where we split out the 70 into its primes. So 70 I can split out into a 2 and a 35. No, 2 times 35 is 70. 2's prime, so I can circle that. 35, can't divide it by 2, can't divide it by 3. Keep checking the next highest prime. I can divide it by 5. 5 goes into 35 7 times. 5 and 7 are all prime numbers. So we can write that as a product, which means multiplication of. That's 2 times 5 times 7. And if we multiply those together, we should get back to the number we started with, which was 70. But the important part is that that's the product of primes, 2 times 5 times 7, and we'll probably see that we'll be doing that in the next week or two. Next up, multiplying by hundreds and thousands, so we've got 12.3 times 100, that's 1,230, and then we've got 3.48 times 1,000. Now, this one sometimes catches people out, so if I just write that like this, and I just put a couple of extra zeros at the end. If I'm multiplying by 10, decimal point goes back 1 space. If I multiply by 100, decimal point goes back 2 spaces. Multiply by 1,000, decimal point goes back a 3rd space, so that is 3,480. So my decimal point has moved now to there. Okay, so that's 3,480. Next up is the factors of 36. We should be brilliant at this, given that the first lesson this week was all about factorizing quadratics, and we would need to be able to list all the factors of numbers. So we start in pairs. So we've got 1 of 36, that's 1 times 36. 2 goes in as well. 2 goes in 18 times, so 2 times 18 is 36. 3 goes in. 3 goes in 12 times. 4 goes in. 4 goes in 9 times. 5 doesn't go in, but 6 does. Be 6 times 6. Don't necessarily need to list it twice, but I will just so we can see them all listed as factor pairs. 7 doesn't go in. 8 doesn't go in, and then we're back to 9. So that's all the factors. Next up, 9 squared, well, it's just 9 times 9 is 81. And 12 squared is 12 times 12, which is 144. That's the numbers. Next up, the algebra. So pause now. And here come the answers. So we're looking to collect our like terms. So I can combine 7x squared, 3x squared to give me 10x squared. Okay, so dealt with that one, dealt with that one. I've got 4x left that I can't combine with anything, so I just need to list that one separately. And then similarly with the next one, we have 4y squared, take away 2y squared. If I have 4 or something, take 2 of those things away, I have 2 left. So I've got 2y squared. So I've dealt with that one, dealt with that one. The take away y is a separate kind of term. I can't combine that with the y squared, but I list it separately again. So my simplified expression there is 2y squared minus y. Next up, solve x. X plus 12 equals 10. Now that's an odd one because there's no number I can think of that I can add the 12 to get the 10. But we can do it because it's a negative starting point. So if we were to work backwards, starting on the 10, do the opposite, take away 12, leaves me with minus 2. So for that one, x must equal minus 2. And the next one, 14 take away a number, leaves me with 20. Well, again, that's quite a tricky one because I have to take away a number from 14 and end up with a high value of 20. And the only way I can do that is if I take away a negative, because if I take away a negative, it effectively means I'm adding something on. So 20, do the opposite, and that's going to get us x equals minus 6. So then if you think of that as that's 14 take away minus 6 is equal to 20, the two negatives there make it a positive. So really what we're saying is 14 add 6 equals 20, which makes sense in context. Next up, simplify d times d times d times d. Well, remember we're adding all the powers together, and the power is 1. So that's d to the power 1 add 1 add 1 add 1, which gets us d to the power 4. Next up, we've got the 4, so I can put that in, and then d squared times d to the power 1 gets me d to the power 3. Because again, I'm adding the 2 and the 1 powers together. Next up, solve for x. Now, getting a little bit tricky here, we've got x take away 4 equals the root of 25. Well, first off, I can simplify that and just say, well, that's just 5 on its own. So if something take away 4 is 5, working backwards, that is 5. Do the opposite, add on the 4 gets me 9. So the first one, x equals 9. Okay, for the next one, and it might become fairly obvious, but what I would like to say is I could simplify the x squared add x squared to be 2x squared equals 8, which means that x squared on its own must be 4. So what number multiplies by itself to get you 4? 2, yeah. So in steps there, that's x is equal to the root of 4, or x equals 2. Next up, some more simplifies. So look for your like terms. Well, I've only got one term in A, so 5a, dealt with that one. I have these two terms in B. 2b take away 2b is no b, so for that one, they just cancel out. 2c take away 3c is minus 1c. I'm going to write that as just minus c. Next one, 2b add 5b is 7b. If I have 7b and I take away 9b, that gets me minus 2b. Next up, 42 divided by something gets me 14. Or think of it the other way, 42 divided by 14 is 3. So for that one, z equals 3. And next one, 63 divided by something is 7. Or working backwards, 63 divided by 7 is 9. So z equals 9. Just make it clear that they were meant to be z's. Next up, some more simplifiers where I can multiply the numbers together. So 3 times 3 is 9. X squared times x, x cubed. Because remember, x on its own is really x to the power 1. And then we've got 5 times 6 is 30. Y squared times x is xy squared. Now, if you've put 30 y squared x, it's still technically right, but by convention we would usually list our variables, that is the letters, alphabetically in highest power first. So if you had x squared and an x, you would list the x squared first. If you had an x and a y, you would list the x first. And some expanding brackets. So 5 times 3y, we're doing those two as multiplication, that's 15y. And then we're doing 5 times 7x. Well, 5 times 7 is 35, so that's plus 35x. And again, normally because we list the x's first, you might have done that as 35x plus 15y. But either would be fine. And then expanding the double bracket. So grid method, if you've got space for it. I'm limited to space on this, so I will do the FOIL method. So that's y times y is y squared. So that's the first two terms. And the outer two terms, so y times minus 5 is minus 5y. And minus 2 times y is minus 2y. And then minus 2 times minus 5 is positive 10. Because remember, two negatives, if you multiply them together, make it a positive. Okay, and then lastly, I just need to combine my like terms. So the minus 5y and the minus 2y will combine to minus 7. So that's y squared minus 7y plus 10. And then lastly, we've got a bit of substitution. It says find the value of v when u equals 5, a equals 4, and t equals 6. So let's write that out. We've got v is equal to 5 for u at at. Now remember, at on its own means I'm multiplying a and t together. So just to make it clear what's happening there, I'm going to say 4 times 6. Now I put the brackets in just to make it clear. Didn't need to, because BidMath says I need to do the multiplication first. So 4 times 6 is really 24. So really that is 5 add 24, which gets me 29. And that's the algebra grid. Right, so as promised, this is much more straightforward than the first one. It's also much shorter. This one is calculating fractions of amounts. Okay, so example 1. It says work out 3/4 of 36. Step 1, divide the value by the denominator. Step 2, multiply the result by the numerator. A lot of people refer to this as divide by the bottom times by the top. So what we're doing is 36 divided by 4 gets me 9. Then I'm taking that 9 and I'm going to say 9 times the top number, numerator 3, gets me 27. Very straightforward process. But again, it's another one of those that if you walk into an exam without being able to do this, it's gonna cost you. It's a straightforward thing, but it's one that we've got to practice so we don't forget it. Example 2, we have 2/5 of 40. So step 1, divide the value by the denominator. So remember, the value is 40. We start with that. We're going to divide it by the denominator, which is 5. So divide by 5 gets us 8. And then we're going to multiply the result by the numerator. So that is then 8 times 2 gets us 16. Again, another straightforward example. Another easy way to pick up some marks on an exam. Example 3. It says 3/7 times 42. This is just another way of doing a fraction of an amount. The word of can just be substituted for the multiplication symbol. So for this one, the process is exactly the same. So we start with the value of 42, divide that by the denominator, the bottom number of 7, gets us 6, and then we take that value of 6, and we're going to multiply that by the numerator 3. So 6 times 3, gets us 18. The only difference there is that this is a multiplication symbol. It doesn't just say the word of, but the process remains the same. Okay, so practice on a few of these. So they're all fractions of amount. Just remember 3/5 of and then the value. So you divide them by the bottom, times them by the top. Where it says 2/3 times or 3/8 times, it's exactly the same process. You're taking your value, dividing it by the denominator, the bottom number of the fraction, and then taking that result and multiplying it by the top number. So pause the video now, and I'll put some answers up in just a sec. Right, okay, so for the 3/5 of, we should have these as answers. For the 2/3, we should have those as answers. And for the 3/8, slightly tricky numbers, but hopefully we're doing these without a calculator. We get those as answers. Okay. Next up, a little bit more practice using some slightly more taxing numbers. Give those a go, see how we get on, and then when we press play, I will talk us through the answers again. Okay, so some more practice questions here. Again, these are a little bit tricky. If you have to use a calculator, feel free, but for these, we should still be able to do them without. We have methods for division, should be able to do the multiplications. So pause the video, give them a go, and I will then talk through the answers when you press play. Okay, so for these, we've got 350 to 450, which we work out to be 270. 265 divided by 5 multiplied by 3 gets me 99. 135 should get me 81. And that one I think is coming to 114. 540, that's going to be 120. 142. 62. 220. 49, 147, 84, and 280. Now, if you did those without a calculator, that's good going. That is quite impressive. If you did need to use a calculator, don't feel too bad because they were quite tricky for without. So well done for that. Okay. Slight extension on what we were doing previously. This one is still work out a fraction of amount, but this is either increasing or decreasing. So remember, increase means we're adding something on, we're making something bigger. Decrease means we're taking something away, so making it smaller. The process is near enough the same, it's just one additional step. So we want to increase £54 by 2/9. So first up, the question is, what is 2/9 of 54? So we'll start with 54. We'll divide it by 9. It's going to get us 6. And I will say 6 times by 2, or 6 times the top number, is going to get us 12. Okay, so 2/9 of 54 is 12. What we now need to do is add that onto the original 54. So step 3, the only thing that was different from the first part was saying 54, add on the 12, gets us 66. And we're working in pounds, so don't forget your unit. So steps remain the same. Step 1, divide by the bottom. So 54 divided by 9. Step 2 was multiply the value by the top, so we had the 6. So 6 times 2 gets us 12. And then the extra step we've done, in addition to what we did previous, is we're adding that on because we're increasing it by that fraction. So 54 add on the 12 got us the £66. Next one, exactly the same process, only this time it's a decrease. So step 3 will be subtract rather than addition. So we'll start with our 48. Divide it by the bottom, so divide by 8. 48 divided by 8 is 6. So we're going to take the 6, and we'll say 6 times by the 3, the top number, is going to get us 18. Okay, and remember that's in pounds. So we need to decrease £48 by 18, so we'll say 48, take away the 18, leaves us with £30. Remember, working in pounds, so don't forget the pound sign. Okay, so I think that should be fairly straightforward. So what I'd like us to do is attempt the questions on screen now. So feel free to pause it, and then when you press play, I will talk through some answers. Right, okay, so looking at those answers, we had increase 27 by 2/3. So think, well, 27 divided by 3 is 9, times by the 2 is 18. So we're doing 27 add 18, which gets us 45. Next up, 27 divided by 9 is 3. 3 times by the 4 is 12, so we're doing 27 and 12, which is 39. Next we're doing 27 divided by 9, which is 3. 3 times 2 is 6, so we're adding 6 on, and that one gets us 33. And then the decrease, so 36 divided by 12 is 3. 3 times the 5 is 15, so we're saying 36, take away 15 is 21. 36 divided by 6 is 6. 6 times by the 5 is 30, so we're taking 30 away, so that one is just 6. And then 7 18ths. Well, 18 goes into 36 twice, so 2 times the 7 is 14. 36 take away the 14 is 22. Again, remember, these are all in pounds, so don't forget your unit. Back in the front, they should have all been in pounds. Okay, so some exam type questions. Attempt these, pause the video, and then when you press play, I will talk us through the answers. Okay, so for the first one, just remember the process. Divide by the bottom times by the top. So that's 96. We'll divide that by 4. That gets us 24. And step 2 is the result, 24 times by the numerator, so times by 3, gets us 72. Working in pounds, don't forget your unit. Next up, fraction of amount, increase £32 by 3/8. So it's the same process, we're just adding it back on at the end. So we'll say 32, divide by the bottom number, so 32 divided by 8 is 4. We'll take the result, which is 4, we'll multiply it by the top number, which is 3. 4 times 3 is 12. And then the only extra step in this one is we need to remember we're increasing £32 by 3/8. Well, the 3/8 was 12, so we're adding that onto the 32. So we'll say 32, add on the 12, gets us 44. And remember, we're working in pounds, so don't forget your unit. And then the last one, it says fraction of amount, 4/9 of a class of 27 are boys, how many are girls? Well, if 4/9 are boys, that must mean 5/9 were girls. So we're going to do 5/9 of 27. So step 1 is 27 divided by 9. That gets us 3. So we divided by the bottom of the original fraction. Then we'll times that result by the top. So 3 times, that's 5. That gets us 15. So in a class of 27, 15 of them were girls. And that's the answer. If you've misread the question and thought, well, I'll just do 4/9 of 27, you're still going to pick up a mark because you've demonstrated you know the process, but ultimately you didn't guess it all right. If you'd worked 4/9 out, that would probably have come to 12 and think, well, 12 out of 15 gets you to 27. Okay, lastly, we've got the geometry measuring data and stats revision grid. So on the next slide, when it pops up, pause the video, work through the questions, and then I will talk through the answers. Pause now. Okay, so first question just says calculate the perimeter, and it's a little bit strange because we're working in fractions and we're also working in decimals. Now, you could convert the decimal parts to fractions, or if we just try to group, say that one and that one, well, 2 add 4 is 6, 3/4 and 1/4 is a whole one. So those two sides add up to 7. We then add on the sloping side of 5.1, that's going to get us a perimeter of 7 add 5 is 12, so 12.1. Sketch an acute and an obtuse angle. Well, there's one angle, there's the other. This is the acute one, because remember acute angles are less than 90 degrees. And this is the obtuse one, because obtuse angles are between, so it will be, say, x is greater than 90, but less than 180 degrees. Next, sketch a four-sided shape with a pair of opposite and parallel sides. The other two sides slope inwards. Name the shape. Okay, well, let's have a think. So, a pair, opposite and parallel sides. So, forgive the bad drawing, but there's a pair of opposite and parallel sides. The other two sides slope inwards. So, it should look a little bit like that. Forgive the poor drawing. What kind of shape is that? That's called a trapezium. And again, there's another lesson on area of trapeziums coming up in a few weeks' time. Rotate the shape 180 degrees. It's usually easier if you use tracing paper for this. It's a bit of a trick you want to do without. But if I started, say, on that point there, and rotated it 180 degrees, in fact, we won't do it about a point because that wouldn't fit on the sheet. If we just rotate it 180 degrees, so what would it look like if I turned it through 180 degrees? It will look like this. Next up, name the shape. That is a cylinder. How many lines of symmetry does this shape have, assuming all sides and angles are the same? Again, I've tried to put these on as neatly as I can. So we've got one that goes down the middle that way. We've got one that goes across the horizontal that way. And we would also have the diagonals going through the middle. So how many lines? That's going to be 4 lines in total. Just draw 1, 2, 3, and 4. How many edges on a cuboid? Well, let's count. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 edges on a cuboid. Next up, this is actually just another way of asking translate this shape. So it says move the shape 1 to the left and 2 down. Always do this point at a time because it's very easy to go wrong. So we're moving that point 1 to the left and 2 down. We'll then move this point 1 to the left and 2 down. We'll then move that point 1 to the left and 2 down. And we'll then move that point 1 to the left and 2 down. So the translated shape should end up here. It's called a translation. And again, we'll do a full lesson on that later on in the course, only we'll be using column vectors for that. And lastly, calculate the area, 2.5 height, 5 width, and it's a triangle. So remember the process, that is base times height and half it. So we'll say, well, 2.5 times 5 is 12.5. And then we're going to half that. That gets us 6.25. Working in centimeters, so our answer is going to be centimeters squared. And that would be the geometry measure. Okay, and the last grid, and this one is data and stats. In particular, note that this one says if you need to, you can use a calculator this time. It says you survey 9 students' height, the average is 165 centimeters. A 10th student is 155 centimeters tall. What happens to the average? Now, assuming it's on about the mean average there, if you introduce a lower value into a data set, the average would drop. If you added a much higher value into a data set, that would bring the average up. So what happens to the average? Decreases or goes down. Words to that effect. Decreases. Next question. A third die was rolled 6 times. It resulted in a score of 1 3 times. What word would you use to describe the outcome? Well, normally, if you were going to roll a dice 6 times, you could expect that one of everything would appear. Obviously, wouldn't always happen, but if we had something in particular like a 1 turn up half the time, when its actual probability of occurring would only be 1/6, I would say that's unlikely. Next up, it says order these values and then find the middle value. Well, if you're good with fractions and can order them as fractions, fine. If you have problems with them, you can convert them all to decimals. So I know these values, but we've already got a process to convert to decimals. If not, it's top divided by the bottom. So 1/5 would be 0.2, 1/3 is 0.3 recurring, a quarter is 0.25, 3/10 is 0.3, and 1/10 is 0.1. So starting with the smallest, we have 1/10, which was 0.1. We then have 1/5, which was 0.2. So listed that one, listed that one. Next, we've got 3/10. We've got 1/4, which is 0.25. Then we've got 0.3, which is 3/10. And then finally, we've got 1/3, which is the biggest, 0.3 recurring. So 1/3. And then we find the median value, the middle one. Well, that's going to be a quarter. It's the one in the middle. So again, if you were working on a larger data set, the process for that is you cross off the 2 end ones, and then you cross off the next 2 end ones until you're left with the one in the middle. Next up, it says from the World Cup graph, who scored the most goals? Well, it looks to me like Kane has scored 6 goals, and he's also scored 3 penalties. So Kane. There we go. From the World Cup graph, how many goals were scored by the 4 players in total? Well, let's put that in. So Mbop looks as though he scored 3, Ronald scored 4, and Lukaku has also scored 4. So in total, that's 17 goals. Not counting the penalties and all that, because that looks to be separate data on the graph. From the World Cup graph, who scored the most penalties? Again, looks to be Kane with 3. From the World Cup graph, what was the modal number of matches played? Well, the matches played in grey, and it looks like we've got 6 for that, 4 for that, 4 for that, and I read that to be 4 as well. So I would say 4 for the matches played. And finally, find an average for the goals scored. State which average you've used and why. Well, you could say that the mode would be 4. I'll do the mean average. So that was 17 goals divided by the 4 players. Okay, now you can use a calculator for this, but I'm going to use converting that into a mixed number. So it's currently an improper fraction. Think, well, 4 goes into 17 4 whole times, remainder 1, and 15 and 4. So 4 1/4 goals on average, or I could even then convert that to decimals and say, well, that's 4.25 goals. That's the mean average. And then it doesn't matter which average you've used. You could have used the median, which would have been 4. You could have used the mode, which would have been 4, or you could have used the mean, which would have been 4.25. It doesn't matter which one you've used, so long as you give an indication as to why. And that would be the data and stats grid. That was another GCSE math lesson from Hartlepool College of Further Education on fractions of amount. Don't forget to check out Canvas for PowerPoint, further explanatory materials, and the quizzes. Any problems, get in touch with your tutor. Thanks.